السلام عليكم ورحمة الله وبركاته. ميرو نسرور chemistry teacher. Our topic today in reaction of alkanes. Why the alkanes are unreactive? Because alkanes are saturated compounds. Every available bonding orbital for each carbon atom is occupied by exactly one atom of hydrogen or another carbon. Because the carbon-carbon bond and the CH bond are very strong, stable, and can't be easily broken. Alkenes do not react with acid, base, or strong oxidizing agent at 25 degrees Celsius room temperature. Alkanes are inert against ionic or other polar substances. Alkanes are called paraffins, lacking affinity. Alkanes' industrial importance. The chemical inertness of alkanes make them valuable as a backbone for structural materials such as plastic. Alkanes are used as starting material in the synthesis of alcohol, plastic, detergent, and fuel. Reaction of alkanes. First one, combustion reaction. Alkanes change from gas to liquid to solid by increasing the number of carbon atoms. Alkanes combustion become harder by changing from gas to liquid to solid. Bigger molecules has greater van der Waals attraction, which make it more difficult for them to break away from their neighboring and turn to a gas. Alkanes react with oxygen to release useful energy. Most of the energy is released as heat, but light energy is also released. Complete combustion of alkanes produce carbon dioxide and water. Alkanes with an even number of carbon atoms are combust harder than alkanes with an odd number. In front of you two equation, the first one C3H8 burning and the second one C4H10 burning. In the first equation, 3 carbon atom used 5 oxygen molecule. In the second one, 4 carbon atom used more than 7 oxygen molecule. In the absence of sufficient oxygen, carbon monoxide and or carbon can be formed. The first equation in front of you indicates a complete reaction or complete burning of CH4. Each molecule needs 3 oxygen molecule to complete reaction. The second one, 2 molecule react with 3 oxygen molecule, so carbon monoxide is formed. In the last one, 1 molecule of CH4 react with 1 molecule of oxygen to form carbon only. Alkanes with small molecules make complete combustion by oxygen to produce carbon dioxide and water. Alkanes with bigger molecules make incomplete combustion to give black carbon and the poisonous carbon monoxide gas. Number 2. Substitution reaction. The first type of substitution reaction, halogenation of alkanes. Halogenation is the replacement of one or more hydrogen atom in an organic compound by a halogen, fluorine, chlorine, bromine, or iodine, in which a CH bond is broken and a new CX bond is formed. The halogenation reaction of alkanes depend on the reacted halogen. Fluorine reacts strongly and can't be controlled. Chlorine reacts slower than fluorine. Bromine much slower than chlorine. Iodine is unreactive. The chlorination of methane takes place in 4 steps. In first step, chlor replaces one hydrogen atom to give chloromonomethane. In the second substitution, it gives dichloromethane. In the third substitution, it gives trichloromethane. In the last one, give tetrachloromethane. Halogenation of alkanes. The chlorination of large alkanes produce mixture of substitution products. For example, a monosubstitution of propane produces one of the 2 isomers, 1 chloropropane, 2 chloropropane. Halogenation of cycloalkane. The chlorination of cyclopropane produce a mixture of substitution products. In the presence of UV light, it can give 1 chlorocyclopropane and 2 chlorocyclopropane. In the absence of UV light, Cyclopropane can undergo addition reaction in which the ring is broken. For example, with bromine, cyclopropane give 1,3-dibromopropane. Due to the repulsion between the bonding electron pairs, the system becomes more stable if the ring is broken. Number 3. Dehydrogenation reaction. Hydrogen atoms are removed and the product is an unsaturated hydrocarbon, as changing ethane into ethylene. Number 4. Cracking. Cracking is the most important process for the commercial production of gasoline. Breaks up heavy alkanes molecules into lighter one by means of heat and or pressure and or catalyst. It yields gasoline and gases such as methane, ethane, ethylene and propane. At the end, thank you and goodbye.